yourself already, but I'm still going to do one thing. So, thanks for coming. If you haven't already done so, please turn off anything that will make noise, cell phones, pagers, whatever. And before I introduce today's speaker, I want to tell you about what's coming up for chats next month. We actually have 2 chats in July. The 14th, Mike Hutzel, a distinguished journalist, is the author of The Price They Paid, Enduring Wounds of War, which is the stunning and dramatic true story of a legendary air cavalry commander and the troops who followed him into the most intensive helicopter warfare ever, and how that brutal experience changed their lives forever. This is during the Vietnam War. And 2 days later, on July 16th, we have Jane McCloskey, who is the daughter of beloved author Robert McCloskey, who will be talking about her father's art and showing images of his work. The chat series is sponsored by the First, 223 Main Street in Damariscotta, a community bank that's grown to serve customers at 16 branches along Maine's coast. Mary Chor is a master gardener in Montgomery County, Maryland, who, since 2011, has lived part of the year in Damariscotta. Mary's Damariscotta garden is magnificent, and she tells me that people are invited to visit it even if she's not there. She'll say more about that, I'm sure. She makes gorgeous flower arrangements, one of which, entitled Free Range Pumpkin, won Most Decorative Pumpkin in the 2014 Pumpkin Derby during Pumpkin Fest. I was going to tell you some of what's up there, but since you can read it for yourselves, let's go on a plant safari with Plant Ambassador Mary Chor.
Really nice to see a lot of smiling faces that I recognize out there, but now you know a bit about me, let me find out about you. If you've ever been to Washington, D.C., raise your hand. Wow, very well-traveled group. If you've ever been to the Capitol, I mean with the O-L, the Capitol building, raise your hand. All right, far out. Check this out. Oops. See the Capitol? Do you see what's right next to it? Hands again, if you've ever been to the United States Botanic Garden, raise your hand. That's quite amazing. Okay, well, you probably don't know this. Everybody thinks when they come to the U.S. Botanic Garden that since it's on the mall with all of the Smithsonian buildings, that it's actually part of the Smithsonian. It is a living plant museum. But in fact, it's part of the U.S. Capitol. George Washington requested a botanic garden to be formed at the seat of government. And eventually, Congress approved that, and the first garden was established in 1820. It was an outdoor garden, and it was in the backyard of the Capitol. Well, the backyard of the Capitol is what we now call the mall. Oops, the mall. And so it got kind of crowded. There was the Botanic Garden there was a train station there. During the Civil War, there were hospital tents. You may have read about Walt Whitman attending veterans on the mall. Anyway, it got kind of crowded, and that was not the original plan. So around the turn of the century, the 1900s, early 1900s, Congress decided we're going to clean off the mall and move everything off to the side. Well, that was actually pretty lucky for the Botanic Garden, because the first conservatory, that is a greenhouse that's built for exhibition purposes. So it's beautifully designed and it has the vaulted ceilings and whatnot. The first conservatory was fairly small, and it was built in 1867. By the time this Macmillan plan took effect, which was to open the vista from the steps of the Capitol to the Washington Monument, it was 1920-something, and the technology had greatly improved. So Congress funded the new U.S. Botanic Garden Conservatory, and it's built just off to the side, but it is still part of the Capitol, and the executive director reports directly to the architect of the Capitol, the USBG executive director. In the year 2000, the renovation was completed. The building looks exactly the same, but it has all updated systems. and it really is a gem, so if you get to Washington, I hope you visit it. Oops, that's the wrong thing. Okay, so why are all these people standing in line to get into the U.S. Botanic Garden? I don't know if you can tell from the slide, but it's hot out. This is the middle of July. Okay? Are they there to see Angus King? No. They're there to see this flower. This is the world's largest flower, but beyond being large, it is also the world's smelliest flower. Now, I told my old boss that I was going to be showing you this slide, and I said, Susan, they're going to be sitting here seeing a virtual Titan arum. I want them to have the full experience. How can I bring the smell? So she actually went to a perfume company that is able to analyze the compounds that create smell, fragrance. They analyzed the smell and came up with a compound to mimic the smell of the Titan arum. And it's in 2 glass test tubes in a glass jar, okay? I am not opening it till the end. But I don't want you to miss out on the experience, but I still want you to stay for the slide. Right? So this is the Titan arum smell, and we will enjoy it together at the end of the slideshow. In fact, I'm going to put it here so I don't forget. Okay, so why would a plant make such a big flower and such a big smell? The whole point, as you might have read in the blurb that you saw in the paper, we're going to be talking about the world from the plant's point of view. You know, we appreciate plants from the human point of view. They feed us, they clothe us, we build our houses out of them, we use them as medicine, etc. So there's many reasons why humans really care and need plants. But from the plant's point of view, plants really don't need humans. They do things for their own benefit. So why would the plant create a 9-foot tall flower with a smell that could knock you out? Any theories?
Keep everybody away.
Keep everybody away.
Out of harm's way.
Maybe it's an introvert. Is that what you're saying? Okay, let's find out. Oh, you know what? This is, okay.
Defense against predators?
That is a good theory. So this is what we know about this plant. It's the rankest, the rarest, the largest, the most flamboyant, and the most famous.
Wow.
The reason it is so big and so smelly is it is indigenous to the rainforest of Sumatra, Indonesia. It only blooms once every 3 years.
Oh.
In fact, ours bloomed once every 5 years because in captivity, which is what I call plants in a greenhouse, it doesn't thrive as well as in nature, okay? So if it only blooms once in 3 years, the purpose of a flower is to make baby plants. The pollen in the flower is what fertilizes the flower egg, the ovum, and gives you a fertilized seed. That's where baby plants come from, right? That's the whole purpose of a flower. Plants do not make flowers for brides to have something to carry, right? They make it for their own use to make baby plants. Okay, so this flower only blooms once every 3 years, and it blooms in this hot, steamy, humid jungle. It has to attract a pollen, and it only is open for 3 days. Okay? So it has to attract the pollinator to come take its pollen and then find another flower that could be miles away. So the bigger it is and the stinkier it is, the more effective it's going to be at attracting the pollinator. And the pollinator is something that's attracted to that terrible smell. For a long time they thought it was flies because they're attracted to dead, decaying meat. It turns out it's a sweat bee who also thinks that smell is wonderful. And the bee flies into the base and it swarms around at the bottom and it gets pollen all over it from the male flowers. They're separated, the male and female flowers are both down there, but they're 2 separate rows, okay? So it gets the pollen on it, and then it leaves the flower. Well, that's not enough. It has to put it at the next flower. So luckily the smell is so strong and the air is so warm. Not only is the air warm, but this is really cool. Where's my pointer? The flowers are down here. This whole thing is the flower holder, okay? It's just a structure to hold the flowers, and they're inside this vase. And this part heats up. You can actually measure the temperature of it. And when the flowers are mature and the pollination is supposed to happen, this area of the flower gets 3 or 4 degrees warmer than the rest of the flower so that the perfume is volatilized, right? And the insects can smell it from further away. It's so amazing. So the little flies or bees, whatever, they go down there, they get covered in pollen, and they can find the next flower, which is 3 miles away. And then they go in because they're attracted to the smell. Do they know that they're carrying the pollen to fertilize the seeds? No, they have no idea. It's not intentional. When we talk about pollinators, bees and birds and ants and whatever, they don't know that they're pollinating the flowers. They're just going after something that attracts them for their own good, okay? So the bees go because they're attracted to the smell of the other flower, and in the process deposit the pollen on the female receptor, which is called the stigma, and voila, you get seeds. Okay, so our flower blooms at the US Botanic Garden, and we think, it's put 5 years worth of effort into making this flower. It wants to have fertilized seeds. Don't we know somebody for him? Not him, him. All right? This is Bill. Bill is our head horticulturist, okay? So he decides maybe we don't let this pollen go to waste. He cuts a hole in the base of the flower where at the base of the vase thing, which holds the flowers. You see, he opens this up. You can see the pollen, the little yellow powdery stuff. He takes it out with a spoon. He puts it in an envelope, and lo and behold, there is a botanic garden in California with a Titan air and bloom at the same time. We mail our pollen. They use a Q-tip. They stuff it down there. They touch our pollen to their stigma. We're proud grandparents. It is so exciting. It is really exciting. Okay, so it did not go to waste. All right. So the Titan arum is really an incredible, unusual plant from the tropical rainforest. But there are many tropical rainforest plants that we are familiar with in our daily lives, but we don't know their story. So the next plant I want to talk about is the banana. This is a nice anonymous woman whose picture was on the internet. I have no idea who she is, but I love the picture. And she is standing in front of a banana tree, okay? Here's the tree, these are the leaves, and up from the center is the stalk coming out in the center that has the banana. So let's look a little closer. This again is back at the US Botanic Garden. Okay, what's happening here? Here's the tree. We're missing the top with the leaves. The stalk coming out of the top gets so heavy that it bends over and falls down. Okay, what are we looking at? First of all, this is not a tree. Okay, that is actually the stalk of the leaves that are clasping each other. Okay, picture celery. You know how celery is stiff? The celery is not wood, right? The celery that we eat is just part of the plant. The leaves come out the top. Same thing with banana, all right? That whole long, what would be called a trunk, is not woody. It's just the stems of the leaves that are clasping each other and holding the leaves up where they can get sun. Okay, so out of that growing point that sends up the stalks with the leaves in the center, when it's mature, it will send out a flower holder again. Okay, remember the Titan arum, the actual little flowers were at the base of the flower holder? It's like a lupin. When you see the lupins in bloom, each one of those little purple flowers is a flower, and it's in a spike. We call the flower holder the inflorescence. All right, so this is an inflorescence. So here we have the first couple rows of flowers were female flowers, and they bear fruit, right? Female bears fruit. Okay. Look at the end of the bananas, the tip. You see the little dried up brown flowers? Those are the female. Do you see them? Can you see it on there? It's kind of like a squash blossom at the end of the zucchini, right? All right. So the first couple rows, and by the way, when we buy them in the store, we call it a bunch of bananas, but in the banana industry, Each row is called a hand because it looks like this. And the whole shebang here is the bunch, okay? So the first like 10 or 12 rows are hands of bananas. Then you see the empty stalk where some ridges exist. And then at the bottom is the inflorescence, the flower holder. Okay, I'm looking at you and I'm like, ugh. All right, anyway, here's a close-up. Okay, all right. So here are the actual flowers. Those are the banana flowers. Now what is that red leaf? Okay, every night about one of those red leaves curls up and reveals a fresh row of flowers. Okay, so when it started, this red football thing was actually at the top of the stalk. And the first row of flowers became the first hand of bananas, and then the next hand of bananas, and then the next. Okay. So then the female flowers have all made bananas. The next rows are all male flowers, and they just make pollen. Okay? So these little ridges on here, that's where the leaves and male flowers have fallen off. So we have 1, 2, 3, 4, 5. It's been like 10 days since the rows have fallen off. Okay. So, how do we get baby bananas? Bananas are actually pollinated by bats. That's why the red leaf opens at night. Okay? Do we have bats at the U.S. Botanic Garden flying around at night? No. Okay. But we definitely have bananas. How did that happen? Turns out that 40,000 years ago, the bananas mutated. Naturally occurring mutation happens all the time. That's why we all look different from each other. And so this mutation was exceptionally useful for humans and other animals because the gene that causes ripening is switched on all the time. Now normally what causes ripening in fruit or in humans? It's hormonal changes that occur after fertilization, right? You get fertilized, you start to ripen, right? You get me? Okay. In the banana, the gene that causes those hormones to be produced is always switched on, so the fruit ripens as if it's been fertilized, but there's no seeds in there. Those little black dots, they are infertile. Those are vestigial seeds. Okay, you couldn't fertilize them if you put the pollen right in. All right. Lucky for us that that mutation occurred because we love bananas, right? So if there are no seeds, where do baby bananas come from? Well, in the wild, those bats do a pretty good job, and the wild bananas get fertilized, and the seeds get big and chunky, and there's nothing really that humans would want to eat after the seeds grow inside. So where do we get our bananas that we eat? Each banana grows in a clump, okay, and it sends up multiple stems. And all you have to do is take your machete and cut off a side shoot and plant it over here, and you have 2 plants. And then again over here, oops, sorry, and again over here. And so eventually you have a plantation, and they're all cuttings from the same plant, right? So that's good because it's kind of a nice, cheap way to reproduce. But what happens if a disease infects or infests the banana? If one banana dies, they all die. It's like the Irish potato blight, right? That's why it was so devastating, because the potato also is propagated just by taking cuttings. It doesn't have anything to do with fertilization of seeds. So that actually happened. The world supply, commercial bananas were wiped out in the 1950s. If you were eating bananas on your cereal in the 1950s, you were eating a variety called Gros Michel. Well, in French it'd be Gros, G-R-O-S, Michel. A disease, a fungal disease hit and spread around the world. Wiped out all of that variety. So now we eat Cavendish. That's the supermarket banana. It's bigger, but it's not as sweet. And that could happen again. So banana researchers, genetic engineers are working on building in disease resistance. But that is a problem. Okay. Now this is really not having anything to do with the point of view of the plant, but I have to tell you because I'm from Washington. There's another type of banana that we don't eat. It is used for fiber in the stalk. It's called Manila Hemp. Manila because it's from the Philippines, hemp because we use the fiber. We do not smoke it. Okay. And here it is. This is how it's harvested. The stalks are cut down and smashed and the fibers are extracted and they're dried in the sun. They're used to make rigging for ships. Does anybody sail? Okay. Before synthetic rope, almost all of the ship rigging was made from Manila hemp. It doesn't decay when it's wet, and it's very strong. But the fibers that weren't long enough were used to make a low-grade paper. And the paper was made not for stationery, but for envelopes and folders. Manila folders!
Oh.
Isn't that funny? And we don't do, I mean, I doubt if our manila folders today are made from Manila hemp. They're probably made from paper pulp like everything else, from another source, but that's where the name comes from. Yeah, I had to tell you that. It's so much fun when I work at the U.S. Botanic Garden and we get office workers coming in from the federal buildings. I always show them this plant first, right? Because they're paper pushers and they can relate to it. Okay, so we talked about the Titanarum is pollinated by those little sweat bees. Oh, by the way, and the banana in the wild is pollinated by bats, but it has a mutation so that we can eat the fruit without pollination. This is a plant that grows in Hawaii. It's very fussy. It's pollinated only by one insect, and that insect has gone extinct. So what's going to happen to this plant? It grows on the cliffs overlooking the sea. So the biologists don't want this last population to go extinct because its pollinator is extinct. So they repel off the side of the cliff when the plant is in flower. They collect the pollen. They scoot over, fertilize, pollinate the neighboring flower, go back. Wait till the fruit develops, because inside the fruit are the developing maturing seeds. When the fruit is ripe, repel back down, harvest the fruit, take it back to the greenhouse, get the seeds out, plant the seeds in pots, nurture the plants, wait till they're mature enough that they can survive on their own, repel back down the cliff, and put the babies back out where they belong. And they're committed to this because this is the last stand in the wild of these plants, and once they're gone, they're gone. You can buy them in a nursery. I mean, they're easy to propagate, and so we probably have 20 of them at the U.S. Botanic Garden, but actually where they originated and where they grow naturally, this is the only stand left. And that's because they only can be pollinated by one insect, and that insect is extinct. Another very fussy flower. This is a type of orchid. Now, orchids are, they're famous for being fussy. They need specific pollinators. They need specific growing conditions. They need specific fungus in their roots to help with their nutrients. It's very hard to grow orchids from scratch. This is the only orchid that we eat, okay? It's vanilla. And vanilla is an orchid that grows as a vine. It comes from the tropical rainforests of southern Mexico and Central America. And when the Spanish colonized that area, they exported vanilla back to Europe. They had a monopoly on the trade, and it became very lucrative because wealthy Europeans really went crazy over vanilla. Okay. Well, it turns out that other European countries had colonies in tropical climates also, and I thought, well, if we could just get some vanilla out of Mexico, we could grow it in our colonies. That's another whole story. Industrial espionage of the age of exploration. It's a whole book. But anyway, they did. And the French started growing vanilla on the islands east of Africa, Madagascar being the biggest one, and then the smaller ones near it, one's called the Union Island, currently. 150 years of growing vanilla, they never got any vanilla beans. Okay, the bean that we use for flavoring is the seed pod. It grows like a string bean, okay? So they had the vines, beautiful flowers, Never got any fruit. Why not? The bee that pollinates it only lived in Mexico and Central America. So 150 years of growing vanilla with no luck to get the fruit until finally a French slave boy named Edmond Albius, 12-year-old boy, figured out how to hand pollinate the vanilla. Okay? And what you do, in the other flowers I talked about, like the banana, there were female flowers separated in space and time from the male flowers. By the way, what's the advantage of having the flowers bloom at different space and time? The male and the female separate? I forgot to grill you on that. Genes, yes, what? Tell me more.
I didn't say genes, I said vanilla.
You said genes.
Well,
It's harder to...
they can evolve and change
Yes.
depending on
Right.
interactions.
You want to have genetic diversity, right? You want to cross-pollinate so we can mix up the genes from this plant with the genes from that plant and get more options for adaptations so that if things change, you have a chance of surviving, right? Okay, if you self-pollinate, if you self-fertilize, you're going to have inbreeding and you're going to end up with cross-eyed bananas. I mean, that is not good. All right, so... No, I lost my train of thought. Okay, so nature has a lot of ways of preventing self-fertilization. With the banana, the male and female flowers mature at different times. With that first plant, the Titan arum, how long? Okay, half an hour. Okay, with the Titan arum, we didn't get to see in there, but there were two bands of flowers, male and female, and they were separated in time also from when they opened. With the orchid, they both mature at the same time. The male part and the female part are in the same flower, so the pollen is ready to do its thing. The female receptor, which is the stigma, is chemically receptive. It's all chemistry, just like with us, okay? But with the orchid flower, there's a physical barrier. There's a flap that the plant creates that keeps these two separate so that it couldn't accidentally pollinate itself, even though chemically and time-wise it's possible. So this slave boy, that was a long way around, this slave boy, Edmond Albius, figured out that he could just use a little stick, push that flap out of the way, take his thumb, push the pollen just down under the flap to where the stigma is receptive, fertilize the flower himself. 12 years old. He figured this out. Do you know that was in 1860 something? And that is how we get all of our vanilla today. Unless you buy vanilla from Mexico or Central America where the bee actually still thrives and it's naturally pollinated, all of the French vanilla from Madagascar, oh, by the way, Reunion Island used to be called Bourbon, so Bourbon vanilla is not bourbon whiskey. It's from the island of Bourbon, okay, Bourbon. And that's most of the vanilla trade today, and it's all from that one discovery of how to hand pollinate. And why? Because the flower relies on a single species of bee to pollinate it, and it has that flap to prevent self-pollination, so it gets cross-pollination and genetic diversity. Okay, should I try the video now? Okay. So we have vanilla, you say vanilla, I say chocolate. So I showed you my little discovery table up here, but let me tell you a bit about the story of chocolate. Chocolate grows right off of the bark of the trunk. You picture the fruit usually coming off the tips of the branches. You know, think of an apple, it's all along the outside. Chocolate grows right up the trunk. And the slide's a little dark, but that's the wood behind it. These are the buds of the new flower. And chocolate, in a way, is like bananas in that it flowers constantly all year long. It doesn't have a season. So it's not like June for strawberries. Chocolate flowers open all year, banana flowers open all year too. So here are the buds. Here's a flower that got fertilized and the new little fruit is forming. Okay. This is a flower after it's opened before it's fertilized. Here is the old flower drying up with the fruit ripening. And here, it's by gnats, little flies, little midges. It's not specific. Any little fly will do. This is what it looks like when it's ripe. Okay, and this is what I brought. So if you didn't get here early, come up to the front after the talk. This is actually the fruit from the cacao tree at the U.S. Botanic Garden, which I kept in my refrigerator for a month. That's why it turned brown. And you can see what the fresh fruit looks like. Okay, so what happens next? It's harvested by hand, machete, child labor, Ivory Coast, bad, bad, bad. And then it's opened. Okay, here's your next plant point of view information. Inside the pod are the seeds surrounded by a white, sweet pulp. Why does the plant make a nice, juicy fruit? From the point of view of the plant.
Something will eat the seed and deposit it somewhere else.
Thank you very much. It's to disperse the seeds, right? It is not so we have healthy snacks, right? From the point of view of the plant, the fruit, first of all, it's not sweet until it's ripe, right? Because inside the fruit, the seeds are still maturing. Once the seeds are ready to be dispersed, then the fruit becomes sweet and juicy so that someone will come along and pick it and eat the fruit and spit out the seeds. And hopefully they will carry the fruit back to their nest or den or tree limb or whatever, and the seeds will fall to the ground and germinate and make a new plant. And by the way, it's all luck. I mean, where the seeds land, whether it grows or not, but at least it's not in the shade of the parent. So the baby is not going to be competing with the parent tree, because the animal will have taken the fruit away. Okay, so that from the point of view of the plant is why fruit exists and it gets sweet and juicy. So the humans, meantime, scoop out all that pulpy white seeds. 1.6 million tons to go. That's the amount that is exported from the Ivory Coast every year, and it's all done by hand.
Wow.
The seeds and pulp are wrapped in banana leaves or chocolate leaves or some other big tropical leaf, just used as saran wrap basically, and allowed to ferment for 10 days in the heat of the tropics. And that's when the flavors start to develop. So if you smell the fresh cacao pod, you're not going to get any chocolate smell or flavor for that matter. But once it's fermented, that's when the chemical process starts. And you get some of the compounds forming that give us that amazing aroma. It's dried in the sun, bagged up, and chipped out. The amazing thing to me is that most of these workers in the tropics have never tasted chocolate candy. For them, it is totally a cash crop. I mean, it's the tropics, the chocolate would melt. But besides that, when the refining process is a high-tech process and it's expensive, and they can't afford it. So they they harvest this stuff, they get it ready, and they ship it out, and for them it's just money. In the U.S., though, every kid grows up loving chocolate. This is the similar display that we have out on the discovery card at the U.S. Botanic Garden. And the children are finding out where chocolate comes from. And you see the same chocolate pod, not the same one, another chocolate pod, like the one I brought for you to look at. Okay, so we've got vanilla chocolate, we've talked about animals and insects as pollinators and how important they are. We know that flowers are the reproductive organs of plants. We know that fruit is the way plants encourage animals to disperse their seeds. Animals are also important for defense. Now we know that animals eat plants, so that would be the opposite of defense, right? They're predaceous on plants. But there's a tree, several trees actually, several species of this acacia tree that use animals as bodyguards. In this case, they use ants. And the ants, see this? That looks like the horns of a Bullhorn Acacia. Ants hollow out those thorns, move in, set up their ant colonies, covering all the thorns of the plant, and they raise their young in there. Oops, I keep thinking that's the advance. Ah, here they are. Ants are eating. What are they eating? This plant values its bodyguards so much that it makes food and drink for them. At the tips of the leaves, these little yellow globs are pure protein for the ants to eat. The plant does not use it at all. It's just to feed the ants. And then, in addition to protein, the ants need nectar. Well, remember we talked about the bats getting the nectar, or the insects. That's the reward they get when they're really after, when they carry the pollen. This little mound is a nectar fountain, and it's not in the flower. Normally, nectar is part of flower production. It's to attract the pollinator. And when the flower's gone, the nectar dries up. All right? With this tree, with this Bullhorn Acacia, this nectar fountain is open all day, every day, all year. So the ants have food, the ants have nectar. And we're not showing the video, whoops, we're not showing the videos today because we're having a little technical problem, but I'll tell you what happens. So what do the ants do? Anytime, this is the tropical rainforest, so there's a lot of plants encroaching on this tree. Anytime a vine tries to wrap itself around it to grow up towards the sun, the ants come and just chomp it off. Leaves fall to the ground. But more importantly, suppose a grasshopper comes to eat the leaves. Then the ants will bite and sting the grasshopper. And when I say the ant, I misspoke. Swarms of ants come out of these thorns and surround the insect and bite it and push it and sting it until eventually the insect jumps away. I've even seen a video, which I couldn't find even to put in the slideshow, of an elephant with its trunk coming and trying to strip the leaves off of the tree. And as it puts its trunk on there and grips on, the ants go running up the trunk, stinging the nostrils, and the elephant pulls its trunk off and starts banging it on the ground. I mean, just to get the ants off. It is so effective. It's an amazing relationship. It's a symbiotic relationship. The ants need the tree needs the ants. Now, we do have this tree at the Botanic Garden, and it is covered with ants, but they're just there for the free food. They don't bite, they're just regular garden ants. Yeah. All right, so, what's next? The tropical rainforest has so many exciting plants. So, let's see, we talked about pollinators, talked about fruit, talked about flowers, what else? Okay, in the tropical rainforest, I mentioned kind of as an aside, there's a lot of competition for light, all right? It's very crowded in there. Most genetic diversity, most diverse, more species than any other ecosystem on Earth. So every plant has adapted a way to outcompete the other plants for light. This is the story of the Strangler Fig. That is not the only thing that gets strangled. Okay? What happens? A fig. You're familiar with figs. All right, there are 400 species of figs. The figs in the jungle, they fruit. The fruits are carried around by birds. The birds eat the fruit and either spit the seeds or poop the seeds, and out they come. The fall, and if it's a lucky spin of the wheel, the seed will fall in a little crack or crevice in a tree up high where the sun shines. Now this seed will germinate. Now normally the seed has to be in the soil, right? So the roots can get moisture. This seed grows as an air plant. Okay, that is a very untechnical term. The technical term is epiphyte, a plant that grows on another plant. No roots in the soil, not terrestrial. Okay, this is a plant that grows with its roots in the air. Now the roots are actually holding onto the tree, But they're not digging in, they're not sucking anything out. So it's not a parasite, it's an epiphyte. So the roots hold onto the tree, so it keeps the plant up where it gets sun. The leaves take in the light for photosynthesis, and it grows right attached to the tree. Looks innocent. But it keeps growing, and it makes more roots, and the roots grow down. And what happens? They touch the ground at maybe 20 feet, maybe 50 feet, but eventually those little roots, air roots, touch the ground and plant themselves. And then they can get nutrients all day, like regular roots can. They don't have to wait for the rain to wash over them and bring all the stuff that's dissolved in the drip water, right? So they get thicker, and they actually get woody, and thicker and woodier, and thicker and woodier, until the poor innocent tree that was just the ladder up to the sun is girdled. You know what happens when a tree gets girdled? It dies, basically. The wood from the strangler fig prevents the original tree from expanding with its annual rings, and it can't grow, and it dies. The strangler fig will actually take over anything it lands on. And so the tree that dies in the center will decay and eventually move away. I mean, not move away, decay and disappear. And you have a hollow trunk inside the strangler fig. This is a view from either the top or the bottom of the strangler fig, seeing where the original host tree has decayed and disappeared. So that adaptation to be an air plant, an epiphyte, is one way that plants survive in the rainforest where there's so much competition for life. Another air plant is the bromeliad, the tank bromeliad. You see them growing up the side of that fallen tree over there. Their specific adaptation is that the leaves of the bromeliad, which is the pineapple family, so picture the top of a pineapple, that's a bromeliad too. The leaves are so close to each other that they form a waterproof cup. And when the rain in the rainforest comes down, they collect the water. So when the rain stops, they still have a water supply. Well, except one problem. Don't plants absorb water with their roots, not their leaves? That's the special adaptation. With bromeliads, they have special cells in their leaves that can absorb the water. That would be like us drinking with our toes. Okay? It's a very unusual adaptation. But not only the bromeliad makes use of the water. Now that there's a little cup of water that persists up in the rainforest when it's not raining, it's there all the time, the mosquitoes lay their eggs and they raise their larvae. And other microorganisms grow in there, and algae and bacteria and whatnot. Well, wouldn't that be bad for the leaves? They'd be all slimy and they would rot. No, actually these leaves have a surface that prevents that from happening. And all those extra nutrients that are now in the water from the waste of these little insects and whatnot, that creates a little nutrient soup. And the leaves can absorb the nutrients right from there. Okay? Because don't forget, their roots are not in the ground. These are epiphytes. They're growing up on other plants. Well, then even bigger creatures make use of it. The upper left is a golden frog, and that frog, its entire life cycle has lived in and around these tank bromeliads. They never have to come down to the ground. They lay their eggs, the tadpoles swim around, they eat all the stuff that's growing in there, frogs mature and hop away. The bottom frog is a poison arrow frog, and it has a slightly different lifestyle. It actually lays its eggs on the ground, which is odd. Frogs lay their eggs in water so the tadpoles can swim, right? The poison arrow frog lays its eggs in a clump of jelly that it secretes. And the male frog fertilizes the eggs, and they turn into tadpoles. The tadpoles crawl up on the back of the mother, and the mother has to carry the tadpole up to the top of the canopy. 2 to 3 days it could take for the tadpole and the mother to complete the journey. But finally she gets up there, she puts the tadpole in the tank, tadpole swims around, has all that nice little junk to eat. But just to make sure, she comes back to the tank every day lays an unfertilized egg for her baby to eat. Right? And then eventually that tadpole turns into a frog and goes back down to the forest floor. I can explain why it's called poison arrow, but that's not a plant story. And neither is this really. Okay, so the jungle, the rainforest, same thing. Competition for light causes a few other major adaptations. Huge leaves, right? My leaf is bigger than your leaf. I get more sun than you get. Pretty obvious. Houseplants. If you can evolve to survive and thrive without much light, wouldn't that be a benefit in the rainforest? Then you don't have to worry about being in the shade. Well, the rainforest, constant temperature year-round, warm, like our house, low light, like our house, rainforest, if you just remember to water them, they will be so happy. And vines, all right? That is one of the major adaptations for life in the rainforest. It looks from pictures of the jungle like the vines are all helter-skelter. Where are they going and why? You know, everywhere they actually are looking for a little bit of light shining through. They don't invest any of their energy in a woody trunk or big leaves. They put all of their energy into fast growth, and they shoot up using anything they can find to hang on to get their leaves up there in light before anybody else. And that's why it looks so random. Okay, so that's another adaptation for the rainforest. You would think with all this plant growth, very lush, that the soil would be so thick and rich and an organic layer like you would die for your garden. The opposite is true, okay? The soil in the rainforest, the organic layer, is 2 to 3 inches thick. And why is that? Well, first of all, it's warm and wet year-round. Lots of microorganisms in the soil. So anytime a leaf or an insect dies and falls to the ground, it decays immediately. And what's covering the ground? The roots of all these plants. So the nutrients are absorbed immediately to promote more growth in the plant. So it's recycling constantly, never accumulating in the soil. There's no leaf litter. It's not like the fall here where you have inches and inches and inches of leaves. Okay. So how do the plants keep themselves upright if there's only 2 or 3 inches of soil? They have buttress roots, or they lean on their neighbor. Okay, and they're all spread out so that they don't fall over. Well, why doesn't the rain wash away this small margin of soil? I mean, it rains every day and it rains hard, right? You have layer after layer after layer of leaves starting at the upper canopy. So imagine all the umbrellas open. The rain comes whooshing down, hits the first umbrella, and that slows it down, and it drips off the sides. Then it hits the next leaves, and it drips off the sides, and then the next, and it drips off the sides. Till eventually, all that kinetic energy from the hard rain, by the time it gets down 100 feet or 150 feet, is just gentle drops onto the soil. Okay? And even the soil may be covered with other plants, so it doesn't wash away. The leaves, it just drips. If we cut down the rainforest, that's when we get erosion. This is an experiment that this fellow is doing on the soil in the prairie. I only show you this, it's not to show you the contrast. These are grasslands. You know, the grasslands in our Midwest and West don't even get enough rain for trees to grow, which is why they are grasslands. Same thing as prairie, right? The soil is 12 feet deep. That's why it's the breadbasket. Okay, it's the exact opposite of the rainforest. It's had a chance every fall. The grasses turn brown, they dry out, they die, they get covered with snow, there's lots of decay, the roots can go way down and the soil gets really thick. This isn't the rainforest. What this is the sunset on our plant safari. And I put this slide in because there are just as many fun plants to talk about and stories in the opposite of the rainforest, the hot, dry desert environment. So if I ever get a chance to come back, that would be my topic. So I just want to thank you for coming on my plant safari with me today. If you're in Washington, visit the Botanic Garden there. And as my English gardening friends say, ta-ta.